So we stopped here yesterday, and really these two problems we could do exactly the same way as we did the other stuff that we did. We can look at these formulas a little bit different, and that's kind of the purpose of this, but these examples aren't great examples of why we care. But I'll explain that a little bit more as we go through it. So we know the velocity, or what we've been using for our linear velocity, is arc length over time. Okay? So which meant if we didn't have the arc length, we had to go find it, and we found the arc length by doing r theta. Okay, that's our arc length formula. So those are equivalent. Then I can rewrite this by taking r out of the numerator and making this r times theta over t. And then that theta over time is the formula for what? Angular speed or angular velocity, which is so r omega. So velocity is r times omega, or it's arc length over time. Those are the same thing, just depending on which part you have. So the reason I think it's good for you to see that you could have the formula in multiple different forms is if you were given the angular speed. If I give you the angular speed, then all you have to do is multiply it by the radius, and then you get the linear speed. Because remember that all circles are similar, so the radius is really like the scale factor of circles. But these, you're not given the angular speed. You're given the same information you were on the other ones. So we will work through them differently, but it doesn't matter which way you do it. You're going to end up with the same thing. We're even going to convert a little bit differently on each one of these. So let's just look at number 8. It says a ceiling fan with 25-inch blades rotates at 40 RPM. Find the linear speed of the tips of the blades in feet per second. All right, so in order to find linear speed, if I want to use the r times omega, we're going to find this. So omega equals theta over time. So remember, to find theta, all we did was take 2 pi and multiply it by the revolutions, which were 40. And so the time is 1, it's revolutions per minute. This gives me 80 pi. This is radians for every 1 minute. Okay. So then I could go ahead and substitute this in and go to find my velocity, or I could convert a little bit here, which is what we're going to do. You don't have to do it here. You could wait and do it all at once, but I want you to see you could do it in 2 different places too. I want feet per second. This is radians per minute. I can't do anything about the feet right now, but I can take care of these minutes. So I can multiply by minutes over seconds so that the minutes cancel out. So this will be 60 seconds and 1 minute. So then if I divide them both by 10, the zeros cancel out. I'm left with 8 pi over 6. And what does that reduce to? 4 pi over 3. So I get 4 pi over 3, and that's radians per second. So I at least have the time converted to what I want. Then I can go and substitute that in for my velocity. So if I'm going to do r omega, the radius is 25, and I'm going to multiply that by 4 pi over 3. That gives me 100 pi over 3, and my units are, the 25 is inches, and the 3 we had converted to seconds. And I still have it like as a horizontal all one thing because I'm not at where I really need to be for my conversions, because what I want is feet per second. I have inches per second. So I'm going to multiply that, inches in the denominator, so they cancel out. 12 inches. I can divide 112 both by 4. And then there's 3's in the denominator and a 25 in the numerator. I can't do anything else with that. So I've got 25 pi over 9, and that is feet per second. Everybody okay with that? We good? Yes. Okay. All right, so then let's look at number 9. It says Ryan is riding a bicycle whose wheels are 28 inches in diameter. If the wheels rotate at 130 RPM, find the linear speed So I'm looking for linear speed in miles per hour. So I'll start by finding my angular speed. Sorry. And that is theta over time. My theta is 2 pi times the revolution, which is 130. And that's for every 1 minute. So that gives me 260 pi radians for every 1 minute. So that's just my angular speed. And I want my linear speed in miles per hour. So again, I could wait and just substitute it in now later, or substitute it now and then convert. Or I can go ahead and try and take care of part of this. Can't do anything about the miles, but the minutes I can change to hours. So the minutes cancel out, so I get 60 minutes in 1 hour. And this is going to give me 260 pi times 60, and that's radians per hour. Now, there's a reason I didn't multiply. Because if it was 2, maybe I would have multiplied instead of like 60, or if it was 20. Or maybe I still would have left it. Because, yes, I can multiply it all together, but we're about to do another step and then have to simplify things. So if I leave it split up, it's just easier to simplify, right? Like, what's the point of multiplying them together and get them big just to take them back apart? So just leave them apart unless it's just something super simple to multiply, like the one above was pretty easy. And that one actually, up here, when I multiplied them together, or when I did that, it actually reduced and made things nicer. Where here, it's not going to make it nicer. I think it would kind of make it worse. So I can use that as what I'm going to go and substitute it in the next spot. So my velocity then is the radius. What's the radius? 14 times 260 pi times 60. And that 14 is in inches. And then the denominator would be 1 hour. So 1 in miles per hour, I got the hours taken care of. And I'm still at this point not going to worry about multiplying anything in the numerator because it's just going to keep making it bigger. And I like the hours. I want to change the inches. So inches in the denominator so that they'll cancel out to feet. 12 inches, 1 foot. Then I need the feet to go to miles. Feet in the denominator so they cancel out. Miles in the numerator. How many feet are in a mile? 5,280. Right, so this gives me miles per hour, and then I'm good, so I can start reducing. All right, well, the first thing I see is that I know divides evenly into 60, so I can make that whole thing go away. I can divide 260 and 5,280 both by 10 to get rid of those zeros. 528 I can divide by 2. It's going to give me 264. I can make that 7. I can divide 264 in half and get 132. And that makes this 13. Don't pick up the purple. So in the numerator, I'm left with 7, 13, and 5. In the denominator, I have 132. Do any of the 3 of those divide into 132? No. What's wrong? Yes, yeah. So then I've got, what I have here then is 7 times 13 times 5 pi, don't forget your pi, over 132. And in the numerator, you can decide what order you want to multiply in. I could multiply 7 times 5, but that's going to give me 35 times 13. That's a 2-digit times a 2-digit. I like to avoid that if I could. I can multiply 7 times 13 first, or 5 times 13. I'm going to go with the 5 times 13. What's 5 times 13? 65. So this is going to give me 7 times 65 pi over 420, and then 7 times 5 is 35. So this is going to give me 455 pi over 132, and that is in miles. Okay, we good? So we're converting and canceling just like the rest of them. Things happen in a little bit of a different order, but it's the same if you do it If you did the whole assignment like what we did yesterday, it's the same thing. Just whatever makes the most sense to you, I guess. Whatever you need in that situation. Any questions? Well, pretty much, yeah. I mean, we're finding the angular velocity first instead of just theta and substituting it in. It's just a different way to approach it, but you could work all of them either way. Well, not every single one. Obviously, if all I want is the angular velocity, I wouldn't do the rest of that, but yeah, you could do the other ones that way. No, I don't care. As long as you understand what's what, it doesn't matter. Are we good? Any questions? Okay. All right, so go ahead and glue or tape this in if you haven't already, and then you have the rest of the time to work on your test review or on this.